Hello everyone. In this video we will look at some examples of asymptotic notations. The first question is, prove that running time t of n equal to n cube plus 20n plus 1 is big O of n cube. That means that a constant into n cube, that is c n cube, will be always greater than this function, that is will be always greater than n cube plus 20n plus 1 for some values of c and n0, where n0 is a value of n beyond which this equation is satisfied forever. In order to prove that, let me divide both sides of this equation with n cube. So I can have the left side as 1 plus 20 divided by n square plus 1 divided by n cube less than or equal to. So we have to prove that this term is reducing as compared to c. Looking at this equation, we can say that this n square and n cube will be increasing whenever the value of n is greater than or equal to 1. Similarly, 20 divided by n square as well as 1 by n cube will be decreasing whenever the value of n is greater than or equal to 1. So when the value of n is greater than or equal to 1, the term on the left hand side will be decreasing. The highest value of the expression on the left hand side will be when the value of n equal to 1. Okay. So when the value of n equal to 1, you can prove that 1 plus 20 divided by 1 square will be 20 plus 1 by n cube will be 1, that is 1 by 1 cube. So this value is 22. So this could be the maximum value of c. When you increase the value of n above 1, this term will be reducing. So that will satisfy my equation if you put c equal to 22. Okay. So in this case, we can fix the value of c equal to 22, and this equation will be satisfied when the value of n is greater than or equal to 1. That means that n0 equal to 1. So this indicates that we can have this equation for some value of c as well as n0. So that means that we can write n cube plus 20n plus 1 as big O of n cube. Okay. So I'm writing the final result here, that is n cube plus 20n plus 1 is big O of n cube. Okay. Now let's look at another example. The question is, prove that t of n equal to n cube plus 20n plus 1 is not big O of n square. Let me write the opposite case, that is, if at all n cube plus 20n plus 1 is big O of n square, then we will be able to write n cube plus 20n plus 1 is less than or equal to some constant into n square. If this condition can be proved, then we can write it as big O of n square. Now our aim is to prove this condition will not hold true for some value of n or c. Okay. So let me divide both sides of this equation with n square. So if you divide n cube with n square, you will get n, and if you divide 20n with n square, you will get 20 by n, and if you divide 1 by n square, you will get 1 by n square, which is less than or equal to c. So this equation says that the left hand side of the equation should be less than or equal to some constant all the time. If you look at the left hand side of this equation, we have an n in the numerator, but here and here it is in the denominator. Here c is a constant and n is the variable which has values above 0. So even if you fix a value for c, as you increase the value of n, this term will be larger compared to the value of c. For example, if you are fixing the value of c at 20, in the next moment if you increase the value of n at some point, let's say 1000, then this constant is still remaining at 20, then this equation will not be true. And if you fix the value of c at 1000, then you can have the value of n equal to 10,000. Then also this condition will not be true because the left hand side will be greater in that case compared to the value of c. So this equation cannot be proved for some positive values of c or n0. So as said in the statement in the question, n cube plus 20n plus 1 is not big O of n square. So I can write n cube plus 20n plus 1 is not big O of n square. Okay. Now let's look at another example. The question is, find the time complexity of the following function. And we have a function which is given in C syntax over here, and the function takes an integer value, and we have two local variables I and j, and the function is not returning anything, so it is a function of type void. And I have two for loops over here. The first for loop is changing the value of I from 1 to n, and the second for loop is inside the first for loop, and the second for loop is changing its value from j equal to 1 to n. And inside the second for loop we have a statement to be printed, that is printf hello. Okay, so it will be printing the string hello onto the screen. So by finding the time complexity of this function, we essentially means how many times the string hello will be printed on the screen, because this is the innermost loop and this is the statement that is going to be executed most of the time. We do not want to calculate the time for every small declaration. We have to find the time taken for the statement in the innermost loop or the statement which is executing quite frequently. In this case, the statement printf hello is executing in every iteration. Okay. So when the value of I equal to 1, the innermost loop will run for n times, because we have the value of j changing from 1 to n. And whenever the value of I is equal to 2, the innermost loop will be running for n times. And when I equal to 3, the innermost loop will be running for n times. And this repeats until the value of I is n. And in this case also, the statement printf hello is executed for n times. So we have the innermost loop executing for n times for every values of I. So if you add up all these values, that is n for I equal to 1 and n for I equal to 2 and n for I equal to 3, and until n for I equal to n, we will have to add these terms. Essentially we will have n number of n's over here, that is n terms. So this sum will be n into n, so this will be equal to n square. So this function execute at a time complexity of big of n square. So you might be thinking that it will be taking some time for these declarations and these assignments, etc. So when you multiply this n square with a constant value, then all those smaller times can be included in that c into n square. Okay, so here the time complexity of this function is big O of n square. Now here the question is, find the time complexity of the following function. So here I have a function with name my function, and it is taking a parameter n, so it is not returning anything. Here I'm declaring a variable I. Here I'm running a for loop for I equal to 1, I into I less than or equal to n, I plus plus. Then I'm printing the string hello onto the screen. Now I want to determine how many times this printf statement will be executed. If you look at the for loop, if it was I equal to 1, I less than or equal to n, we know that this function will be executing n times. But here we have given this I into I, or the square of I should be less than or equal to n. Then we have to determine how many times the printf statement will be executed. It is simple to find. We have the condition I into I should be less than or equal to n, which means that I square should be less than or equal to n, or in other words, I should be less than or equal to square root of n. Whenever we have a value of I which is less than or equal to square root of n, only then this condition will be true. If I is equal to square root of n, you will have square root of n into square root of n. So either side will be n less than or equal to n. So in that case, the condition will be satisfied. Whenever the value of I go just beyond square root of n, then square root of n plus something into square root of n plus something will never be less than or equal to n. So this condition will be false. So the loop will be terminated. So this statement will be executed square root of n times. So we can write the time complexity of this particular function as big O of square root of n, okay, or n raised to 1 by 2. Okay, so this is the time complexity of this function. The next question is, find the time complexity of the following function. So we have a function void function int n. The function is taking a value n, and we had two local variables I and j. Then we had two for loops, an outer loop and an inner loop. In the outer loop, the value of I is varying from 1 to n, and in the inner loop, the value of j is varying from 1 to n. But the difference is that at every iteration we are doubling the value of j. So that is why j equal to j into 2 is written over here. Then we are printing a statement hello in the innermost loop. One can definitely say that the outer loop will be executed for n times, because the value of I is changing from 1 to n and there is no change of I happening inside the inner loop. Now we have to examine how many times the inner loop will be executed. For a given value of I, the first iteration of the inner loop will be with j equal to 1, and in the next iteration the value of j will be 2, because we are multiplying j with 2, and in the next iteration the value of j will be 2 into 2, or 2 square, and in the next iteration the value of j will be 2 square into 2, that will be 2 cube, and this process will continue on and on. So let's assume that the value of j has gone up to 2 raised to k. At that instant of j equal to 2 raised to k, the value of 2 raised to k is becoming equal to the value n. Okay, so we can easily find the value of k from this equation. That is, if you take logarithm on both sides with a base 2, then on the left hand side I can write k, then on the right hand side I can take the logarithm of n with respect to the base 2. So the value of k can go maximum up to log n. So we can write these terms as 1 was 2 raised to 0, and this was 2 raised to 1, then 2 square, then 2 cube, then all the way up to 2 raised to k. So in total we have k plus 1 terms. Okay, so when we write k equal to log n, then the innermost loop will be executed for log n plus 1 times. Outer loop will run for n times. The inner loop will run for log n to the base 2 plus 1 times for every value of I. So in total we have n into log n plus 1 times. If you multiply this expression, then you will have n log n, I am omitting the base, plus n. In this expression, the term with highest growth will be n log n for a very large value of n. So I can neglect this one, so I can write it as big O of n log n. Okay, so this is the time complexity of this particular function. And the next question is, find the time and space complexity of the following function. Here you have a function, the function name is sum, and it has an array A, an integer variable n, which possibly indicates the size of the array, and an integer variable x equal to 0, and an uninitialized variable I. We are running the for loop from I equal to 0 to n minus 1. We are incrementing the value of I in each iteration. Then we have a variable x getting updated with the previous value of x and the new value of A of I. Essentially, this for loop is computing the sum of all the elements of the array A. Then we are returning the sum into the calling function. And if you look at this particular function, you can see that this is the statement that is going to get executed depending on the value of n. The number of execution of this statement depends on the value of n. So this is only a for loop, so it will have a time complexity proportional to n, or the time complexity will be big O of n. Similarly, the size that is required for this array will be depending on the value of n. There is a proportionate amount of space that need to be used for the array A. And similarly, you need space for storing the value of n, you need space for storing the value of x as well as I. We have three different variables, so we can say that we will have three different integer variables, but you compare with the array size will be depending on the value of n. Essentially, you will have n plus 3 integers consumed in this entire function. That is, this is for the variables n, x and I, and this is for the array A. Depending on the value of n, the size of the array is increasing, and this 3 does not increase depending on the value of n. So the significant amount of space is used only for the array A that depends linearly on the variable n. So the space complexity will be also big O of n. Okay, so this is the time complexity and this is the space complexity. I hope the idea is clear. Thank you.